So let us now try to solve problems involving bodies floating in a fluid. So we'll just be applying Archimedes principle in order to solve this problem. So for problem number 1, we have find the volume of the water displaced and the position of center of buoyancy for a wooden block of width 2.5 meters and depth 1.5 meters when it floats horizontally in water. So the density of wooden block is given by as 650 kilograms per cubic meter, and its length is 6 meters. So basically the dimension of the wooden block is 2.5 by 1.5 by 6. So for the given, so we have the volume of the block is 1.5 by 2.5 by 6 meters, and the density of the block is 650 kilograms per cubic meter. So based on the problem, so we do already have its free body diagram. So we consider the weight of the wooden block and also the buoyant force resisting the weight of the block. So we are asked to solve for the volume of displaced fluid, which is water. So, and also, we need to determine the location of the center of buoyancy. So, to determine the location of the center of buoyancy, we just need to get the depth or the draft, then divide it by 2 to determine the location of the center of buoyancy. Since the location of the center of buoyancy is just the centroid of the immersed body. So, to solve for the volume of the fluid, so we just have to apply equilibrium equation. So, we sum up forces upward, positive. So, we have buoyant force is just equal to the weight of the wooden block. So the buoyant force is simply the specific weight of the fluid, which is water, multiplied by the volume of water, then it is equal to the specific weight of the block multiplied by the volume of the block. So in this problem, we have a given volume for the block. So we still have to determine the specific weight of the block. Okay, so to determine the specific weight of the block, we just have to convert this mass by I to weight. So to convert the mass to weight, we just have to multiply it by 0.00981 kilonewtons per 1 kilogram. So let's substitute all the given. So the specific weight of water is 9.81 kilonewtons per cubic meter. Then the volume of water is 2.5 by 6. So 2.5 times the length, which is 6 meters. Then the height is h, equals to the specific weight of the block. So we just have to multiply the density by the acceleration due to gravity, or simply we convert the mass to weight. And the volume of the block is given as 1.5 by 2.5 by 6 meters. So we solve for the h. So h is equals to 0.965 meters. And then we can now solve for the volume of the water. So which is 6 meters, which is the length, 2.5, which is the width, and the height is 0.965 meters. So we have the volume of the fluid, which is 14.625 cubic meters. And then let's now proceed solving for the center of buoyancy. So for the center of buoyancy, so we'll just have to divide this h by 2 to determine the centroid. So we have 0.965 divided by 2. So the next problem would be a wooden block of 4 by 1 by 0.5 in size and of specific gravity of 0.75 is floating in water. Find the weight of the concrete of specific weight 24 kilonewtons per cubic meter that may be placed on a block which will immerse the wooden block completely. So we already have a given free-body diagram. So the forces involved are the weight of the concrete, then the weight of the block, then it will be resisted by the buoyant force. So the given are the volume of the block, then the specific gravity of the block, then the specific weight of the concrete. Then we are asked to solve for the weight of the concrete, which will immerse the wooden block completely. So as you can notice, the wooden block is completely immersed in water. So that means to say that the volume of the block is just equal to the volume of the displaced fluid. So to solve for the weight of the concrete, we just have to apply equilibrium equation. So we sum up forces vertically, then we assume upward positive. So we have the buoyant force is equals to the weight of the concrete plus the weight of the wooden block. So the buoyant force is the product of the specific weight of the fluid and the volume of the fluid. Then we have to solve for the weight of the concrete. Then the weight of the wooden block is also the product of the specific weight of the block and the volume of the block. So let's substitute all the given. So the specific weight of water is 9.81 kilonewtons per cubic meter. Then the volume of the displaced fluid is just equal to the volume of the block, which is 4 by 1 by 0.5. Then it is equals to the weight of the concrete plus the specific weight of the block. So in order to solve for, in order for us to determine the specific weight of the block, so we just have to get the product of its specific gravity and the specific weight of water, which is 9.81 times 0.75 multiplied by the volume of the block. So obviously we have 4 meters by 1 meter by 0.5 meter. Then we solve for the weight of the concrete, which is 4.91 kilonewtons. For our last problem on the buoyancy, so we have from the figure below, it is shown that the gate is 1 meter wide and it is hinged at the bottom of the gate. Compute for the following. So we're asked to solve for the hydrostatic force in kilonewton acting on the gate, then the location of the center of pressure of the gate from the hinge, and the minimum volume of concrete needed to keep the gate in closed position. So let's solve for the hydrostatic force in before we solve for the unknowns. So first thing to do is we have to draw the free body diagram. So in drawing the uh, free body diagram, so we have to solve it by members. So first member is we have the gate, so we have to isolate the gate. Then the second member is the free body diagram of the concrete block. So for the free body diagram of the gate, so we have, so the forces involved are the hydrostatic force exerted by the fluid onto the gate, then so which is HP, or the location of the center of pressure. So it is H bar plus E away from the free liquid surface, and it is uh, so the distance from the hinge up to the uh, resultant force, or the total hydrostatic force, which is represented as Z, which is equals to 2 minus H sub P. Then we have also the tension uh, exerted by the pulley. So we solve for the hydrostatic force F. Okay, so for F, so we simply apply the formula for the hydrostatic force, which is the specific weight of the fluid times the location of the centroid of the plane surface times the area of the plane surface. So the specific weight of the fluid is 9.81 kilonewtons per cubic meter multiplied by the location of the centroid, h bar. So since the total height of the height of the gate from the hinge up to the liquid surface is 2 meters. So to determine the location of the centroid, we simply divide it by 2, since we assume that the gate is rectangular in shape. Then we have also the area of the gate, which is 2 meters height by 1 meter width. So the total hydrostatic force is 9.62 kilonewtons. Then we are also asked to determine the location of the center of pressure relative to the bottom, or relative to the hinge. So first thing to do is we have to solve for H sub P. And we all know that H sub P is equals to H bar plus the eccentricity, which is I bar over H bar. So H bar is 1 meter, then I bar is BH cube over 12. So we have base is 1 meter, height is 2 meter raised to 3 over 12 times the area is 1 by 2 meters, then H bar is 1 meter. So HP is equals to 1.333 meters. Then to determine Z, or the location of the total hydrostatic force relative to the hinge, so we have 2 minus HP, so we have 2 meters minus 1.333, which is 0.667 meters. Then to determine the tension, so since we have here a hinge, so we just apply equilibrium equation by taking moments at the hinge. So we take moments at the hinge. So we assume clockwise positive. So we have the hydrostatic force times its moment arm, which is Z, equals to the tension multiplied by its moment arm, which is 2 plus 0.5, which is 2.5. Then let's substitute all the given. So the total hydrostatic force is 19.62. Then the location of the total hydrostatic force relative to the hinge, which is 0.667 meters. Then let's solve for the tension. So the tension is equals to 5.23 kilonewtons. And lastly, after we analyze the free body diagram of the hinge, the gate, so we can now proceed with the FBD of the concrete block. So The forces involved are the weight of the concrete, then the buoyant force since it is immersed in fluid, and also we have the tension coming from the pulley. So from the FBD of the concrete block, so to solve for the volume of the concrete, again, we apply summation of forces vertical. We assume upward positive. So we have the buoyant force plus the tension equals to the weight of the concrete block. Then, buoyant force is the product of the specific weight of the fluid and the volume of the fluid, plus the tension, which is already solved. So, equals to the specific weight of the concrete times the volume of the concrete. So, let's now substitute all the given. So, the specific weight of water is 9.81. Then, the volume of the fluid, since it is the concrete block is completely immersed in the fluid, so the volume of the fluid is just equal to the volume of the concrete plus the tension, which is 5.23 kilonewtons, equals to the specific weight of the concrete, which is given as 23.6 kilonewtons per cubic meter, times the volume of the concrete. Then we solve for the volume of concrete, so the answer will be 0.33 cubic meters.